All right. So, hi everyone. I guess more people are coming in, but I'll just get started. My name's Joseph Abrahamson. I'm around in a lot of different places by Tel, my middle name, on Twitter by STBO. And I want to talk to you about a library that I've been writing in Scala that I call Maya. And as a quick little aside, I made a logo for it because I thought that was cute. Maya is one of the Pleiades, I think, is a Greek mythology thing, which ends up being a constellation, which was a pretty cool logo. So the big one is Maya. And what I'd like to do today is kind of talk through what Maya is, why I think it's an interesting library, why I spent some time working on this, and also to talk a little bit about some interesting things that I did in the implementation of Maya. And there's at least two different aspects of this. One, Maya is a, you could call a type level library, in that it does really bizarre things with types. And part of my interest in writing it was to see just how far I could do really bizarre things with types in Scala and get away with it. So I'll talk about that for a little bit. And then two, I honestly think that there's a chance that Maya could be a really useful library for you in practice. It's not completely built yet, and I'll talk about where I'm at with that toward the end of the talk, but I do genuinely think that I'm bringing together some very interesting ideas that solve some very practical problems with writing often REST APIs, but web server client APIs. I'm attracted to this problem because I've faced these problems in the past. I'll talk a little bit about them a little bit later in this talk, and if they reflect with you and you like working on really cutting-edge, bizarre type Scala things, then maybe this could be an interesting fit, or maybe in the future it'll be an interesting fit. So Maya, composable type design, type-level web API design. Here's this stuff. I guess, okay, I can't move my computer. These slides are going to be up on the GitHub, I suppose, later. I'm not sure when that's going to go up, but links to everything will be there and the slides will be available. I also want to mention that there is a Haskell version of this too, so if you guys are more interested in Haskell, I kind of wrote the two things in parallel so I could work the design on one language and then work it in the other language in order to see how things would match up. So if that's more interesting to you, I don't know how to make GHC.js work, but it's there as well. All right, so let's dive in. Maya is an API construction kit, as I've been calling it, for building composable APIs that work at the type level. And so much of this talk is basically to break down that sentence and try to make that more clear so that both the ideas that I'm working with are more approachable, like they're not standard Scala things, and so using them this way, I want to make that a little bit more familiar and approachable. And then two, to see how using these kinds of techniques can hopefully really solve problems for people. So I think that Maya brings together two big ideas that sort of solve these problems. First is composable APIs. Honestly, I'm stealing a lot of these things from GraphQL, so if you're familiar with GraphQL, this is the same kind of composability, but I find that when I've been working in REST APIs in the past, you don't necessarily have as much reuse and composability as you might expect. There's some desire in like the principles of REST and the way that fundamentalist REST is supposed to work, that you can kind of reuse the code that you've written and reuse the endpoints that you've written, but a lot of times in practice around team communication and around the evolution of these kinds of things, I feel like you don't get the same kind of composability that you would want. And so there's an idea that there's some more composability in the way that this works. And then two, type level specifications allow you to boil properties and invariants of your APIs all the way up into the type system. And I mean, I'm kind of hoping that everyone here has some familiarity with Scala at least, and so you have some excitement about the idea of things being in the type system because you're familiar with the idea that when something is in the type system, you can by and large forget that certain things can go wrong. If it compiles, it works. Like, there's a variety of ways that that can succeed or fail for you, but to some degree, if things are in the type system, if it compiles, it works. So one slogan that I try to think about here is if you're familiar with the idea that you should sort of put all of your defensive coding on the boundaries of your application, all your parsing and your failure modes and all those things, push those out to the boundaries. Like, that's a pretty common idea. And then you get this idea that I feel like you have with a server and a client. If both of them have this pushing the defensiveness out to the boundaries, you have these two big fortresses. It's really fun working inside your fortress. You feel safe, you feel like you understand everything, a lot of things cannot go wrong. But when you have them actually communicate, they have to go through this no man's land between your safe typeful fortresses, and that becomes really difficult. And so I think what Maya and other type level API projects like this can do is they can sort of help you to build a bridge between these type level fortresses, or these strongly typed fortresses, where you can pass data and feel comfortable that it's safe, and feel comfortable that you don't have to worry about how it's going to get mangled as it goes between the two fortresses. A lot of those ways of going wrong have been statically removed from your concern. So that's kind of really high-level ideas of what I'd like to think of Maya and what I'd like to convince you guys is true about Maya. But let me back up for a little bit. First, overview. I'm going to, in a minute, talk a little bit about the problems that I think Maya faces in a little bit more detail than I have so far. I'm going to go through, kind of at a high level, what are the pieces that I've worked on in order to create a solution and have it work in the types of Scala. And that'll give kind of an overview to what I was calling type-level programming in Scala. And then at the end, I'm going to talk a little bit about the status and the results. Now, if we go through this really quickly, and with regard to that, if anybody has any questions, feel free to just ask them. I'm totally interested in interaction, and if that's useful for understanding, just go ahead and ask questions. But if we get through it very quickly, at the end, I also have some slides on more of the details of how this stuff is being implemented. So if you're interested in how you can really push shapeless to a certain limit, or if you're interested in how type-level functions work in Scala and kind of what the limitations there are, if we get that far, I'd like to talk about that stuff too. So kind of start out with the really general stuff and see how far we get into it. And then before I get started with any of that at all, I want to make like a little tiny screed about why anyone should even care, or why moving in this direction could even be interesting. It's certainly complicated. I'm going to make types that are politically complicated, are indecent. Like, it's not normal typing. It's hard to necessarily accept that as a good thing. And so I just want to make a general statement about why it might be interesting to go in this direction at least. And so I'm going to bring out perhaps my old friend, or a lot of people's old friend, of the Curry-Howard correspondence, which, if you're not familiar with it, is this idea that if you look at proofs in mathematics, which are sort of like one way to think about a proof is it's this crystallized knowledge. If I have a proof, then I have the ability to convince somebody of something I've learned. And you take proofs, you can correspond them with programs that we write, totally normal programs, things that we all do all the time, presumably in our day jobs or our hobbies or whatever. Those two things correspond. At the same time, propositions, a proof is attempting to convince you of a proposition, 1 + 1 = 2. If I have a proof of that, then that proof has now substantiated that proposition. The correspondence to that in programming is types. And so, in some sense, a proof is telling you this is crystallized knowledge about some fact or idea that you'd like to care about, or you presumably care about. And so the correspondence I'd like to kind of bring out is to say that in programming, your programs are some kind of crystallized knowledge, like you've worked really hard to figure out how something works, and the thing that you are solving for can be reflected into the type. Now, oftentimes you end up with types like these, which are corresponding to extremely boring propositions. Int is the proposition that there is an integer. There are a whole bunch of proofs of that. I can give you 6,000 of them if you want. Unit is the proposition, is the proof of absolutely nothing. If I prove unit to you, then you literally, nothing changed in you. You already knew that. Any is a proof of nothing at all. There's not any meaning to that at all. And like string to string, like if you're more interested in some of the more parametric or aggressively kind of typed ideas in Scala, then you might think string to string is kind of a dangerous type because you can do a lot of things with string to string. It doesn't give you a lot of information. And so the idea that I'd like to put forward, and I'm attributing it to myself right now, is that the best way, because I have to say it if I'm going to quote myself, so the best way to unlock and communicate the meaning of a program is to give it an interesting type. And so with that little thing aside, I want to talk about some, I think, relatively interesting and perhaps bizarre types, like this one. To kind of jump to the end of this whole story, you can write a function called serve, which is parameterized over your entire description of your API. And will convert requests that match on that API to responses on that API. And all of the data types must line up. All the ways that the API go wrong must line up. The multiplicities of things must all line up. The arguments to all of these things, like all of the pieces just must line up, and it's all being parameterized by something complicated like the actual API that you use to communicate between your server and your client. So that's an interesting type, I think, and that's where I'd like to get to. Any questions so far?
What's the lesson column your API, lesson column API, what's the lesson column?
In order to parameterize this function by some type, I need to know a little bit of information about that type. In this case, that's a subtyping relationship, which allows me to say that your API here, which is a type that you've defined, is a subtype of all APIs. And then I can... Right, yeah, same idea. So, yep, precisely. So cool. Any other questions? If not, I'll jump into a problem that I feel passionately about, and I hope that if anyone else has ever written server-client APIs, they will reflect and feel similarly about some of the problems that can crop up when you're doing this. So, an API is a contract between two different people. You agree that you're going to communicate in a certain way, and you're going to agree that certain expectations about that communication are acceptable and that people can trust that those things will exist. And when you're working, like I want to imagine a server-client application, because that's your standard web application. I want to imagine kind of like one of your fancy, thick client JavaScript style, heavily interactive applications. You can also imagine maybe there's a server team and a client team. And so this contract actually becomes really important because as each one of those applications evolves, as each one of those teams grows and learns, they need to maintain that contract with one another so they can keep moving together. Otherwise, you end up with, at best, bugs, but possibly just large miscommunication that causes you both to be unable to grow because you've kind of made assumptions that can't be broken anymore. You need to maintain backward compatibility, or just cause a lot of confusion and slowdown and difficulty. So a question I would ask is, presuming you've worked on a project like this, did you write down what your API was specifically? Okay, some nods and raised hands. Did you maintain that, or did you feel like you did a really good job maintaining that? Do you feel like it ever drifted from the actual practice of your API? Do you feel like the person that did that documentation hated their life? That's painful, it's difficult, and if I'm a new hire and I'm reading that documentation to understand how the API is, then that semantic drift is going to be some amount of pain that I'm going to have to overcome. Which I guess I just talked ahead of my slide. But yeah, if it drifts, how do you manage those communication flaws? If you have multiple different ideas of what the API is, do you recognize the pain that's being caused by that, or is there a lot of pain being caused by that, or do you have some other ways to make sure that the communication is tight and people do have the same idea of what the API is? Or this one's one of my favorites because despite no matter how hard I try to make sure that we don't do these kinds of things, I frequently find that you end up in applications where in REST APIs you've written one amazingly specific endpoint that is specifically providing exactly the data that one view needs. And I don't want to necessarily say that that's a bad practice, but I do feel like it couples your client work with your server work, because if the clients need slightly different data, they're going to have to ping the server team, and maybe everyone is a full stack developer and has no trouble doing all that writing themselves, but there's still this communication divide that needs to be crossed every time you make a change. And so this is kind of tight coupling that's occurring. I'm totally guilty of writing these because they're super convenient, and at many times that's the right thing to do, but it does induce a sort of pain point. So on top of these kinds of ideas, I want to make a really wide sweeping assertion that you may or may not agree with, but I'm going to assume is true for the remainder of this talk, that REST APIs are often really complicated, often underspecified, and they don't solve certain client use cases around data fetching, in particular how clients evolve their needs over time and how the API catches up with that. So hopefully the things I'm saying here do kind of feel like war stories that some of you are familiar with. I'm getting some nods, so hopefully this is a real problem. I certainly feel like it's a real problem. I have beat my head against this kind of thing and the various associated and follow-on problems with this a lot. So given that that's the problem, Maya is going to try to be a solution for this. a new API architecture typed. And as I hinted at earlier, I'm totally just cribbing GraphQL. I think GraphQL had some really interesting ideas here, and they solved a lot of these problems. And if you're familiar with GraphQL, then maybe you already know where I'm going with a lot of this. If you're not, then I'm actually going to be like going through some of these design decisions as I keep going into this. I originally wrote Maya trying to make a GraphQL library that worked at the type level. Ultimately, I backed away from that because GraphQL is kind of really complicated and a little bit tailored to JavaScript specifically, I feel. So this is kind of a reimagining of GraphQL if Facebook wrote everything in Scala instead of all sorts of things, but JavaScript specifically. But GraphQL has some really good ideas, and I'm going to be cribbing from that and kind of working back from those ideas. Yes?
Maybe I should ask Sangria, but there's another library for Scala.
Yes.
GraphQL.
Sangria?
What's your motivation?
Yes.
What's your motivation to
So there's a real motivation and there's a marketing motivation. Real motivation was there's a library in Haskell called Servant, which does this type level API stuff that I really like. And a lot of the benefits that I've been proclaiming that Maya might have, I'm stealing from my experiences working with Servant. So I really wanted to bring those things over, and I was wondering if I could even do it in Scala. So that's the personal motivation. The kind of marketing motivation is those things itself. Like Sangria works at the value level, and therefore the kinds of guarantees that you can get from specifying your API, specifying your GraphQL structure in Sangria are not as strong as the ones that I think you can get from Maya. So, I mean, practically, if you need to write a GraphQL endpoint in Scala, use Sangria, absolutely. Not only is Maya not compatible with GraphQL, it's not completed yet, and also will be a lot crazier. But I do think there are really interesting ideas here, and maybe those things are things that could be ported back into Sangria or something like that in time. So, yeah, it's a really good question. I probably should have mentioned that earlier, sorry. Any other questions? Cool. So this is kind of what I would pull out of GraphQL. It does a lot of things, but I think it achieves pretty much the thing I was saying that I think Maya achieves. It has a composable design, which, again, I'll get into in a minute, but it's very good to just take a new entity and stick it into your API and have it work very nicely with everything that's already there. And two, it actually has a static specification. Like when you use GraphQL, you write down a bunch of documents that must match your API, and if they don't, they have various processes which will yell at you and tell you that you violated your contracts. So like it does actually achieve a lot of these things, but it's all in JavaScript and it's all external to Scala's type system. So I feel like the work to make that line up is a little, the workflow is different. It's not as nice as static typing as you might be familiar with in Scala. And so maybe we can do better. So what I'm going to do now is just start rebuilding the ideas of GraphQL as I kind of see them in Scala and using a lot of types. So I think the heart of GraphQL and I think the heart of Maya comes from just the relational model of data, which I think is already a pretty good way of talking about data. It's already pretty composable. If you add a new relation, you can add links or add a new table, you can add relations to that table from things that you already exist, and you can keep growing this. It composes very nicely. If you are good at making a super normalized schema, which we'll kind of end up doing, then you don't have too many difficulties with duplicated data or anything like that. Like the thing will grow relatively nicely. So I want to work to begin with from basically a relational model. So here's a running example that I'll be using for the next couple slides. We have a person and a city. A city can have a mayor. A person can have a hometown. Presumably, sometimes the mayor's hometown is the city that they're the mayor of. And then also a person can have a mother, and then their mother can have a mother, and their mother and their mother can have a mother. And so you link that relationship off forever. So this sort of, these are kind of very natural relations to consider in like a entity relationship diagram or database design or something like that. Like we have no concern with thinking in this very graph-oriented kind of point of view. But if you go to implement it in Scala, you're going to run into one problem if you do it super naively, and that's that these are potentially infinitely large data types. In this case, I implemented this pretty much as naively as possible, and you run into the circumstance where, at the very least, you're going to have to specify every city and every person so that you can completely cover the person, the mayor hometown relation. But you're in a ton of trouble if you start trying to cover the mother relationship, because then you've got to specify someone's entire ancestry. And I guess you can do it with like lazy vowels or something like that, but you can't really do the ancestry problem unless you can write out all of the people. So this is kind of what I would like to do and the way I think I would like to think about data, because if we just pretend that these small problems of having to deal with infinite amounts of data aren't really there, then this is a really nice world to work in. If I have a person, I can ask who their mother is, I can ask who their mother is again, and I can access all the data that I need from any point I am in this graph with a lot of ease. So this is kind of like the ultimate place that we would like to live in, but we can't quite get there because it's kind of large. So this is kind of where I feel that the nice trick about GraphQL and the nice trick about library design like this is, even though we think of data and we would like to consider data that is potentially infinite in size or recursive in such a way that we can't easily handle it or we can't easily work with it, we'd like to consider a world like that. We actually can get away with that as long as we recognize that the actual work that we do on this data is always finite. By which I mean, even if I have this infinite representation of this data, at any point in time, I'm only going to be caring about some finite amounts of it. I'm only going to be asking for this person, their hometown, and their mother, and maybe their grandmother, not all of the data that can possibly exist. So the step that sort of unlocks this sort of design is to start considering finite requests and finite responses. Another way of looking at this is if you have a graph, like a graph has loops inside of it, and those are exactly the things that we were running into a minute ago. But any graph, you can ask for a spanning tree, you can unfold from a particular point and get a tree out of it that's only finitely large. And so that's exactly the kind of data type that we're going to work with instead. So let me introduce those. So this is very similar to the type that we were working with before. Previously, we were just specifying the data itself and had trouble, but now we're just going to ask for requests about that data. So again, if you look at this type, it's providing a sort of spanning tree of that infinite data structure that we were looking at a minute ago. For atomic types, like the person in the city's name, we just need to know whether or not you want that piece of data, yes or no, true or false. For recursive data types, we just need a request of the appropriate type for that recursive data type. But if you're not interested in going down that relationship, then just provide us none. You're not requesting it, we're not going to respond to it, and that will terminate this infinite data structure and let you deal with just a finite chunk of it. So I feel like I talked a lot, but I hope it's relatively clear how that relates completely to the previous data structure. But this begins to be something that we can actually work with and talk about meaningfully, and also is pretty much all we would ever actually need. We don't need to have that infinite data structure. We just can work with these. Just to prove that they are real and can exist, like here are some examples, some very simple examples of actual finite requests that might be meaningful to do. You could imagine your client constructing requests like this and sending them to the server and saying, get me this amount of data. And the server just needs to respond with data that's sufficient to match this request. Then likewise, here are some responses. For a response, you have a question? Yes.
So does the person request again trigger like city request?
The city request is just a sub request that's being used in the person request.
This person also has a city, right? Would that then trigger like some kind of recursive?
It can't, because you would have to, I mean, it could if you use like lazy vowels kind of pathologically, you could construct that kind of thing. But you can also talk about just a finite one, because in this case, the person is requesting the city, right? It has that city request embedded inside of it. But since the city request that's embedded inside of it does not request the mayor, it terminates right there. So that's why you always end up with a finite request instead of having to keep spanning like that previous data type. So you just need a bunch of places where you can kind of terminate the recursion. And so by replacing all of these fields with an option instead of the actual value that we're trying to get to, I can terminate that recursion whenever I need to. So I'm doing the exact same thing with the responses, except the only difference is now when we get to these atomic values, the names, we actually need to provide the data instead of just saying true or false. Do we want the person's name? Yes, we'll give you a string. I guess in both cases, we'll give you a string if you ask for it. So this request and response data type, hopefully, like I hope this is a really fairly simple example. There's not too much stuff going on here. You could already work with this. If you create like a Circe JSON serializer for these types and start sending them back and forth from the server, this is already solving all the problems that I'm talking about. You've got some nice types. This is very composable. If you want to add a new relation, you just write new types like this, new request and response types. You write new serializers. You'll have to write a server implementation that turns requests into responses, but like, barring this enormous amount of boilerplate, like this is already achieving all the things I said I was going to achieve in the first place. It's composable and it's nicely typed, and if you actually worked in that world, you couldn't go wrong. You couldn't make a request that was invalid to this API, and as long as your server implementation is correct, all the responses will come back and match the requests that they're supposed to be servicing. So hopefully, to some degree, like I'm already done. I can walk out. This is the way you should do it. Here. Just write a ton of serializers, a ton of data types, and make sure you never make any mistakes. I guess here's an example of a response, in case you were curious. My hometown is Atlanta, so this is me. So I'll talk about the boilerplate in a minute, but I also want to say that what I've said so far probably suffices in a certain way. This would be enough to solve certain problems, but it's not terribly interesting yet because realistic APIs are not so simple as this. You don't just have gets off of particular pieces of data. So there are 4 extensions that I'd like to talk about at least briefly. I guess 3 extensions and also handlers. So I'll talk about this first. This is, if you wanted to write a server, you need a server that converts requests of these types to responses of these types. This is a way of thinking about that. You can say that the way to handle a request for somebody's name is a task on the name, which is just a way of talking. It's like a future on getting the name. So if you need to go do a database lookup or something like that, then you can return it in this task type. The hometown is just a task of whatever the sub-response is. So you're going to get the whole response according to whatever the request that's coming in is. And right now we can write that type that I said earlier, the very interesting type that I said earlier. We can take a handler like that, and maybe this is clear, maybe this isn't clear, but I promise you that if you had that data in that handler, then you could take a request, use that data from that handler, and construct the response that matches the request to be able to send back to the person. Yes?
The task of person, should that be person response?
The task of person.
In-person handler, you have mother, you have task of person.
It's a task of person because the mother of a person is a person again. So when I look up somebody's mother, like I need a task that will go fetch that person's mother. And then.
Why city response? I guess I'm having trouble.
Oh, I did make a typo here. It should be person response. Sorry. Yeah, good catch. Yeah. So. Oh yes.
So like those like 3 tasks will be executed independently, right? So you need to like send like 3 requests to a database or something like this?
I'm at this moment, like that would be in the implementation of serve. If you wanted it to be parallel, great, make it parallel. If you only can do it in serial, then do it only in serial. There is like a data dependency thing, like the assumption is that all of these are independent, and I suppose to really get into this, when you look at one of these handlers, you have to already know the person that you're working from. So if you're really to define this in practice, you'd probably have a function, a definition that says, given somebody's like user or person ID, here is a handler for that person ID, so you can go look up things. You've got enough information to make parallel lookups, for instance. So it's kind of up to you the way that you want to do that, but I'm just saying that this would be enough information to construct the responses if you needed to. So these are handlers, what I'm calling handlers. They're the server-side implementation of this API. to extend the API to get some interesting pieces, you can do things like local errors. So I'm going to change person response to say that when you ask for somebody's mother, you don't just respond with definitely their mother, because there could be the chance that we don't actually know who that person's mother is. Like, presumably that will eventually happen because we run off the end of the ancestry records or something like that. Like, they had a mother, but we don't know who it is. So it's really important in APIs like this to be able to specify errors that are occurring. And in practice, when I was playing around with this, it's really important to be able to decide what type of error you want to deal with within the API, because each different kind of request that you might be trying to make could have, or each different like field, mother, hometown, whatever, they could have different ways that they fail, or some of them might never fail. They're unconditionally successful, and you don't want to accidentally, it would be difficult if you also had to be worried about those things failing, even if you knew that they couldn't. So at the type level, we go ahead and specify that these things cannot fail. Yes?
Is that unknown relation? I ask for a mother, but that person doesn't have one, or I can't determine who the mother is.
Yeah, like as the server, we've got a really big ancestry database, but you did mother 4,000 times, so
Okay.
I don't know. That's as far as we go. Yeah, but it's just an example of any kind of error that could happen when you try to look up somebody's mother or their hometown or whatever in a more advanced or expansive example. Another thing that's really important is multiplicities. If you're returning like an atomic value, like their name, you could just return like a list of names. But when you're returning, in this case, we can look at extending the person response to get the list of their friends, which you know that I was reading a bunch of Facebook stuff since I'm talking about giving people's friend lists. But if I want to talk about someone having many friends, then I need to actually start specifying that there are many possible responses at the type level, because I'm only going to pass in one request for what I want about their friends. I want the names of all of their friends. So I'll give it a friend request or a person request to the friends field that only asks for the person's name, and then I'll get back a list of all the names. So you need to actually have that interplay exist at the type level, unlike what you do with, like, if you need to get the person's, I don't know, like birthday present. That's a terrible example. If you need to get something very atomic, then you could just pass that back normally. But for these nested relations and these nested queries, then you need to actually tell at the type level how many you need to get back. So you can do exactly 1, 0, or 1, or many.
How would you say that you want to name like all of these friends' names, for example?
Mm-hmm.
How would you request to get it like name yourself?
Yeah. So in this case, you'd be making a person request, right? So person request, sorry. There's some other stuff that you're doing in here, friends. And remember the request, if you're requesting something that has the type of friends is another person, right? It's another big object. So what I pass into it is an option of the request, right? So I'll pass into it some person request. And then in this case, I'll just say, yep, name equals true. And let everything else be nones and falses. Like you just let those be the default values when you define these types, and then you can just write name equals true.
Yeah, but like if you want to like give like type friends, what would you do?
Right. So because friends is just a relation that we know is has a multiplicity of many, when the response comes back, which is the type of the response, right? It's going to return a vector of those things. So it'll get the many just by the nature of it being the thing that you asked for. It might make a little bit more sense later. So if you still have this question later, ask again.
So if you go to GraphQL, you usually put that as a parameter of friends saying a limit of 5.
Yes.
Do you do that with this model? Or
Arguments. Which totally, like, I was writing this thing, and I was like, oh man, it worked, this is so great. And then I tried making my first like example API, and I was like, immediately you run into this problem without being able to parameterize by arguments. You either end up with extremely difficult to use ones or just extremely boring APIs. So parameterizing them by arguments. Each one of these different fields you could pass in an argument, and in this case, like a limit is a really good example of an argument. Now, GraphQL I think has some more support for doing this more generically, but I'm keeping it simple. So yeah, those are the extensions that I wanted to talk about, the ones that I've implemented in Maya, the ones that I think if you get all those together, you actually have the ability to write some very interesting API specifications. You just need to consider, again, local errors, multiplicities, and arguments, and you can have a really rich language. I said it, a really rich set of tools for building composable APIs. Yes?
So why did you model friends as an option of vector, not simply an empty vector in response?
Not simply an empty?
Simply an empty vector. So you ask for friends, there are no friends. I'm going to show return you an empty vector.
You could do what you're doing, because we have a little bit more information when we're working like this that allows us to be a little bit more efficient. About to take everything up a level of abstraction, and at that point you can't do that anymore because I need to distinguish very generically between you didn't even request friends and you requested friends and you actually have 0 friends, which is sad. All right, so this is where we're at. I feel like this design gives us a rich set of tools for building composable typed APIs with loads of terrible boilerplate that you will probably make errors on, and I would never actually recommend that you do this. Like, okay, cool, that I guess gives you the properties that I said that you wanted at the beginning of this whole thing, but it would suck. So I'm going to do something that I called abstracting over templates, which hopefully is vague right now, but will make sense in another like 3 slides. So here is this type that we were just dealing with, person request. Here's another type, person response. Hopefully, if I flip back and forth between these slides really fast, you'll notice that they're relatively similar in that most of the information here is the same. And what I would like to be able to do is just specify that constant information and have the library deal with the small differences between these things. So the differences are request versus response, which is a library concern. It's not your concern, it's my concern. So this is the type I'd like to write. Person of something, and then you have a string and a city and a person, and that's the actual information that matters in terms of talking about the API. So the question is, how can we do this in Scala? And I think that I don't know how familiar people are with higher kinded types. This might be an obvious step, this might be not an obvious step, but hopefully it's not too complicated to figure out what's going on. If I parameterize the person by some kind of type that has a hole in it itself, then I can just wrap each one of these interesting types in that parameterized type and have something that kind of is exactly this ... version that isn't a real type at all. So what I'm positing is that what this is trying to mean is actually captured by this guy. So again, if you're familiar with higher kind of types, this probably is very simple, but if anyone has any questions about how this is working. Oh, yes. I'm glad you asked. You can imagine, so like where's an eraser? Here's an eraser. So I have this this new type, person request, and I'm parameterizing it by f by this guy. And what that's saying is, if you want to, like, say val x is of type person request, the thing that I pass in right there when I instantiate this type needs to be a type that itself has a parameter, right? So I can pick like something kind of silly. I could pick option. So if I pass in option, this is now a valid type, and if we replace f in this thing over here with option everywhere, we'll get this guy. So that's effectively what I'm doing. I'm parameterizing over the not particular holes in the type, but instead contexts in the type. And actually, if you think about it, option is not too far away from what we want. This is pretty close to response type. Actually, yeah, pretty close to the response type. So what I would like to suggest is, at least at this level of complexity, what I'm doing is really not too terribly complicated. It gets gnarly later, but this idea of just plugging in the right kind of type to transform the contexts that are wrapping around the different subtypes, field types in there, is kind of the whole trick. As it turns out, for practical purposes, which should translate at all points in now and future in this talk as IntelliJ, we need to give it a little trait bound here. So what I'm saying is that instead of just passing in any f, I'm going to pass in an f that is a subtype of this DSL thing, which just gives me two contexts I can pick from. We'll call it the atomic context and the object context, or the nested context, which is kind of space words right now, so I'll just show you how that works when you actually implement it. Instead of just wrapping all of these with f, we're going to parameterize it by some DSL, or some instantiation of the DSL. And then I'm going to take the name and I'm going to wrap it with the atom piece of that DSL. I'm going to take the hometown, I'm going to wrap it with the object piece of that DSL. And those two are sufficient to get the structure that I need out of this. So that's another level of a little bit more complexity. Hopefully this is making sense. Does anyone have any questions about what I'm doing here? I'm using type projections, which are not usually, they're a little bit non-standard Scala because they're kind of confusing and they don't necessarily do exactly what you expect that they do. But when you're working like this, they actually behave really beautifully. So hopefully this makes sense.
Is there a reason why you don't parameterize it using a value x of type big X and type was x dot Haskell and x dot?
Yes, because when you do that, then you need to actually have, so that would become a dependent path type, right?
Yeah.
And then I would need to actually have particular values for these DSL instantiations, which does not work with some of the more complicated ones that I use later.
I'll see what it goes.
I'm not actually going to cover that one here because it gets a lot more complicated, but we can talk about it later if you're interested.
This can be expressed with type plus in Haskell, right?
Yes, you.
DSL would be a type plus and atomic object are like methods of type plus.
I think you probably could do it. Like I said, there is a Haskell version of this, so if you want to talk, like we can talk about that later, or you can take a look at it. It's not the way I implemented it. I implemented things a little bit differently because I don't think a type class would work really well for this, but I do think you're right that you could do something like that. You'd really need an associated type, which is kind of what these guys are as well. But yeah, we can talk more about that later. Cool. So hopefully this kind of makes sense. I'm not doing anything too much more complicated than when we passed option in a minute ago. I'm just passing in a slightly, instead of just asking for f to be something that has a parameter hole in it, I'm asking for it to be two things that have parameter holes in it. In fact, if I wanted, I could have made the types look like this. Shit. Oh, excuse me, sorry. I could have passed in two contexts, but there's two problems with that. One, that means that you might pass in one kind of atom context, another kind of object context, and get confused. And two, that's ugly. This is also kind of ugly. I don't like it. I wish I could find a better way, but it's less ugly than this. So if hopefully this is making sense so far, I'm going to dig into some implementations of types that are extending DSL, because we'll need a bunch of them. So here's the first one, the easiest one, request. Request is a type of DSL, an instantiation of a DSL. And the way it works is that the atomic value of any type, if you're asking for the request, is just a Boolean, which if you remember was exactly what we did. If you wanted somebody's name, you just need a true or a false. The object or nested one, and this is kind of gnarly, right? This is a object is being passed a type, which is a type that is parameterized on a type that is a DSL. If that makes sense, it makes sense. If not, then just try to pretend like it doesn't exist when you see all that stuff. It just means that this is like a API style type, a big nested, complicated one. But if you have one of those, then you just need to return an option, so maybe, sometimes, or maybe not, that type with the request DSL passed into it. So another way of saying that is a request of that type. So hopefully that looks really familiar because it should have been the thing that we just looked at a few minutes ago here. I'll make that more clear in a minute, but that's how you instantiate requests. And I gave it an object. I don't actually think I need to do that now that I think about it, but anyway, ignore that part. Sorry? When we pass that DSL into person, it becomes X here is going to become that DSL, right? And then I'm calling object with person, so person becomes the T. So T here kind of stands for type, but it tends to mean like the API style type, one of these big, more complicated one with fields inside of it. Right. So there's
The
requests.
T is from the T's can be like type, right? Like and so the person is just a type, right? But T is type to type. So how would that work?
That's a really good question. You caught me on a little trick I'm doing. So hopefully it'll make sense in 3 more slides. Here's response. It's pretty similar to request in that the only thing you really need to do is change request to response in the object and change Boolean to maybe optionally the actual value that the person requested. So again, like these should all be the same patterns that we saw earlier, but I just abstracted them out and put them into this DSL style of context. And then we can take a look at the values that we were working with before. Here's person request, the same one that we were working with before, the really boilerplate heavy style one. And I can change it to this. And you'll notice, kind of magically, that the only thing I had to change was the constructor and the type. So what I'm hoping that
Shouldn't you also change the person request in other, for example?
Yes. Thank you. Oh, man. Yes, that should be person brackets request. It wouldn't work otherwise. And then hopefully that answers your question earlier about why the person needs to be parameterized. Okay, we can talk later if you want. So hopefully all of this has been hoping to convince you that what I was able to do with this system was parameterize, or to abstract away these templates, by which I mean a named type with a bunch of fields, and each field is associated with whatever you'd be looking up if you went and got that field. I abstracted that piece out and I separated it from the request and response details and was able to pull those away entirely. And that is kind of the whole key to unlocking how you can evaporate all of the boilerplate of the stuff that we were looking at before. So I'm going to get a little bit more deep into this next. We got about 10 minutes left, but if anyone has questions so far, I'd love to answer those as well. Sweet. This slide was kind of not. This slide is just saying, because I'm going to be using it in the future, that up until right now I just said person brackets request when I wanted to talk about the request of a person. That ends up getting really annoying because you kind of want to say request of person. So these are just some type aliases I'm going to use that allow you to flip it around. That little form.request is the object that I defined. If this doesn't make sense, just look at the bottom here where I say a person request is a request of type person. That's what I'm trying to do here because it's nice and reads well. And hopefully now that this is a little bit more clear, we can actually, I'm not saying how I could write this value. I'm going to pause it. I'm going to tell you that I have written this value. You can write this value. It's a little bit more complicated than that, but you can actually conceive of and think about this very interestingly typed value. However you want to define your API as this big composable nested set of API types, that's this T type here, the your API from that earlier slide. And I can write a server that generically responds to any request on that API and gives you a response that matches that API.
It's a typo.
Where's the typo?
You have 2 opening square brackets and 1 closing one.
Oh, yes. Just, man, thank you. It's
It's meant to be 2 closing square brackets on the right-hand side.
Actually, no, it's the second opening bracket shouldn't be there. T is,
Right.
oh no, you're totally right. There's a, actually no, this is, yeah, T, it should be T brackets underscore subtypes DSL. Ugh, yeah. Again, that's like the ugliest thing, and if anyone knows any way to get rid of that, I would love to do it because I want Maya to have as like parsimonious and simple of an interface as possible, despite all the gnarliness that's happening underneath. Hopefully, if what I've said so far kind of makes sense, that would be the only actual interactions that people actually need to do when using the library. So that is a certain kind of like ending point that I was hoping to get to. Like, this is how you can construct, you can abstract over something kind of bizarre, this like template abstraction, and you can start talking about types that are fairly interesting. And I can just leave it right here and say, I promised you that I can write a function that actually does that thing. The next slides are getting a little bit more into depth about how you actually write these things. And also, if you notice, I kept everything simple and I didn't include any of those 3 extensions, which means that everything that you can write like this is pretty boring, but you can actually include all 3 of those extensions. So with that, whatever 8 minutes we have left, either I can answer questions or I can get a little bit more details about how this is being implemented. That one? All right. So here is what things actually look like. That DSL type got a lot more complicated because I started including these object K, which is a terrible convention. I don't know why I did it. Object K stands for object configured. I don't know why. I'm not German. I don't even know if that's how you say it in German. But hopefully this example gives you a little bit more picture of what Maya would actually look like. When you have a person, in this case, we're going to return a person type from this field lookup. But it has an argument, the person's person ID. It used to be user, but I like person more. You need to pass in the person ID that you actually want to look up. So that's an argument that you need to do. So you say this has arg person ID. It doesn't have an error, so you have to tell it no error. And you tell it the multiplicity it wants, or the size. So you get one person back if you give me a person ID. Now that I think about it, it probably should have had an error if you give like an incorrect person ID, but just pretend like that better example was used and not this one. Or down here, get all persons. You get a person, there's no argument to that, you're just going to get all of them. There's no error because the worst I can do to you is just return no people because I don't know anybody. And so you're going to get many people back from this response. So we've enriched this DSL type to make this X thing be able to say much more complicated pieces. And that's kind of what I was saying earlier, this richness of the type language. Like we actually have a lot to work with here. And you can write all of those out as Scala types. So.
Can you express like if you want to like get those 5 friends or something like this? Instead of maybe using something which contains data, it's a number of friends you actually want to get.
Yeah. For that, I would say just put it into the arg. Like GraphQL, again, like I think has like a way of specifying a limit when you're getting a multiplicity back like this. At least just for my own simplicity at this point of implementing this, I said you can put that in the arg if you wanted to, so that's enough. Maybe there's a better way, but that's what I have right now. Was there another question? Okay. So the question is, how does this work? Because this is a pretty gnarly type. Everything in that is a type. Has_arg is a sealed trait. Person ID is a type that you define. No error is a sealed trait. No error extends error spec. Like there's a whole bunch of type nonsense going on there. And so the way that this all like shakes out and gives you exactly the same behavior that we just talked about a minute ago is type level functions, which is the other way that you use type projections in like an enormous amount of anger. These work really well in that they're really hard to use and they're kind of terrible, but they actually do exactly, when you figure out how they work, they do exactly what you think they do, and they do it very nicely. And the compiler, Scala, actually does a great job with them. It will compile many things that are tricky and feel like it won't quite work. IntelliJ won't, so a big design decision for me was make sure that IntelliJ feels happy about everything that you do in Maya, so there's some limitation about what I'm doing here. But the way you can read this is, so I'm defining a type, right?
Just a question there.
Yes?
This is a very interesting point with a lot of function programming and calculating. So to turn it around, why not just write it the way you want and then fix it in IntelliJ? So it's not
Fix it in IntelliJ?
yeah, fix the presentation compiler in IntelliJ. It might be less work than
That's a really potentially, I don't know anything about IntelliJ's like internal compiler, so that would be hard for me to do personally, but there is a design of this that I experimented with for a little while that's a lot nicer that I walked away from because IntelliJ was broken. So it did constrain my design space. And if you know more about how to improve IntelliJ to handle these kinds of things, like I would be really interested in that actually.
it's all Libre. You wouldn't fix it.
Yeah, for purposes of designing this library, I felt the easier path for me was just to simplify it. But it does work in Scala. There is a nicer interface that does actually compile just fine, and it was literally just IntelliJ. So that's a really reasonable option if there was a way to get those improvements put into the compiler. Yeah. So what's going on here, if this is really confusing and mind-blowing, in that it is really confusing and mind-blowing, and it took me a really long time to get all this to actually work, is I'm defining a type, that same object K that we were looking at just a minute ago, and I'm saying that there are 4 arguments to it. And really at this point, the types are becoming values. You should just think of this as if I was defining a value with 4 arguments. This is a function definition, really. So type object K takes 4 arguments. The first one is just that funky T thing that defines APIs for us, because we're going to return an object of that type. The second one is constrained to be an arg spec. The third one's constrained to be an air spec. And the fourth one's constrained to be a size. And then down here at the bottom, I take the arg spec and I use the type projection that I called provide. I take the air spec and I take the type projection I called provide. I take the C and I use the type projection I called call for collection. And I just combine all these things together. It's super gnarly because I haven't told you what provide is. I haven't told you what call is. You don't know what any of these things are. But what I want to say is what this is just method calls. It's method calls happening at the type level. And if you can rewrite whatever you're trying to do into a bunch of method calls at the type level, then these kinds of type functions more or less will work very nicely. I've only got 2 minutes left, so there's a lot more detail I can go in on those things, but I just wanted to say that what you end up doing in order to make this work is you just have to give a little bit more structure to these types. Air spec and arg spec are traits that these things extend that define, provide for me. They're just classes that define these type members, these methods. So it's actually very parsimonious with normal Scala programming, just up a level and you change val to type and you just change dots to hashes and things kind of work out the same way. And then the other big trick that makes everything work is this really crazy trick in implicit resolution, in that at compile time, when the Scala compiler is searching for an implicit that satisfies all of the constraints it needs to do, I have full access to all the types and I can do recursion on those types and structural analysis of those types. And so that's really the bulk of what Maya is me taking these types that we've talked about today, structurally analyzing them at compile time, searching for the right implicits to do whatever I need to do, such as implement serve or implement JSON serialization, and then providing all that for you generically. Sorry? Okay, well, cool. Thank you, everyone. That was what I wanted to talk about.